Welcome friends, welcome to your channel Think and Top. In this session, let us learn about least common multiple, also called as LCM or sometimes lowest common multiple. This is our third session on concepts, and concepts are very important. They are foundation of any subject. Once you have clear hold on concept, you can easily solve complex problems. And now we are ready to move. Before we move, as I always say, remember to visualize the problem, visualize the situation, concentrate, stay focused, use problem solving technique, which is a good one, which is easier to do, which is more accurate. And for using problem solving technique, you need to be familiar with formulae and theorems. LCM is a tool to accurately predict interrelationship between behavior of two or more numbers. So now you understand what LCM is. It is about relationship between two or more numbers. What is LCM? What is it? Let's see a definition. When we have two or more numbers that are non-zero whole numbers with us, LCM helps us in finding a common number. A common number, what a common number? The common number that is the first or least common whole number divisible by all these numbers. Alternatively, you can say that the first common whole number that is a multiple of all those given numbers. Let us see an example over here. What is the LCM of 60 and 72? We will use a theorem over here, formulae, well proven formulae, that is called prime factorization. What is it? What we have done is that we have broken 60 into its prime factors, that are 2, 2, 3 and 5. The product, when you multiply these, you get 60. We have given space over here. I'll tell you why. When you go forward, you will see why this space has been given. 72, it can be broken up like this, 3 times 2 and 3 and 3. So this makes 72. What are prime numbers? Prime numbers are basically those numbers that are divisible by either 1 or by themselves. Like 2, 3, 5, 7, 9 is not a prime number, 11 is a prime number, then 13 is a prime number, and so on. Now we have to stay focused over here. What we are going to do is that here we will multiply common prime factors of 60 and 72 and their individual prime factors once. So what are the common prime factors? This is the common prime factor. The next one is this. The next one is this. Now what are the individuals? This one, then 3, and then this 5. What we are going to do is that we are going to multiply these things. Like from this we have got 2. From here we have got this 2. From this 3 we have got this 3. These are the 3 common prime factors of 60 and 72. And then we have individual 2, 3 and 5. So what do we get? I have just rearranged it to look it nice. It looks nice like this. So 360 is the LCM for 60 and 72. The other method is that you have to look at the table of both the numbers. Like 60, this is the table, and 72, this is the table. We have made the table till 360 because we just want to stay focused for the LCM where we get it. So 360 comes over here at the 6th number for 60 table, and for 72 it comes at 5. So this is the first common multiple that is appearing on both tables. We have marked them. So we can say that looking at these two tables, 360 is the LCM for 60 and 72. But is this a good idea or this is a better idea? We'll see that. Let us see for 3 numbers now. We'll carry forward the example 1. We already had 60 and 72. We are including one more number in this series of 84. Now let us break into the prime factors. 60 is like this. We have already got 60 and 72, and 84 is broken like this. 2 into 2 into 3 into 7. This is 4, 4 3s are 12, 12 7s are 84. Now again we will do the find out the common factors first, the common prime factors of 60, 72 and 84. What are those? 2, then again this line shows, then we have this. And what are the individual ones? This 2, this 3, this 5 and this 7. Now we will multiply them. 2, 2, 3, then again this 2, then this 3, then this 5 and this 7. Rearranged it for it to appear nice. So 2520 is the LCM for 60, 72 and 84. Why do I say that this is a better method? Because if you look at when we multiply 60 with 6 and 72 with 5, we get 360 as LCM. Good. This is a smaller table. We got it early. But what is the case in the next example, example 2, when we have 84 as well? When we multiply 60 with 42, 72 with 35 and 84 with 30, then we get 2520 as LCM. So you can see how many times you have to multiply. The table will go long, very long, it will take more time. So we will stay focused on prime factorization method. That is a better method. So this is how you find the least common multiple for 2 or more numbers. The first step is to break it into its prime factors, each individual number, then look for the common numbers, the common prime factors and the individual prime factors, note it down and multiply them. Now do you know that where do we apply LCM? I will give you one example. As I said that it is a great tool that predicts interrelationship between the 2 or more numbers. So LCM is a unique tool to find a minimal possible number that is divisible by all numbers whose LCM needs to be identified. Where is its application? Where do we apply LCM? I will give you one example. LCM is used in space applications. When we use mathematics in space applications, they are called as space maths. So LCM is used in calculation in space applications, that is called space maths. You agree or don't agree with me, I don't know, but when you look at this example that I am going to give, I am sure that you will agree with me. This is an example from NASA. We are thankful to NASA. Suppose Mercury, Venus and Earth are the 3 planets that last came up in one line in 2020. When will be the next time when they line up together? How do we know? We have certain information about their behavior. Mercury takes 1/4 of an Earth year and Venus takes 2/3 of an Earth year to make their complete orbits around the Sun. Now this is a very vital information. So courtesy, we are very thankful to the National Aeronautics and Space Administration of United States of America. Now this is the picture. Look like this. When they come in one line, there are 4 planets over here, but we will focus at 3. So what we have to do is that we have lined up 2 methods for you to understand. The first method involves LCM and the other method is a different method, and we will verify the answer from both if we get the same number or not. Now method 1, the common denominator in this case is 12. Remember, Venus is 1/4 of Earth year, Mercury is 2/3 of Earth year and Earth is 1/1. We can write 1 as 1/1, there is no issue because the denominator is 1. Now the series periods are, for Venus 1 numerator and 3 is the factor for denominator to 4 to reach 12. So we can write over here as 3. So 1/4 can be written as 3/12 over here. Similarly for Mercury, we have 2 as numerator and 4 as the factor for 3 to reach 12. So we have 8 as a product out here. So 2/3 can be written as 8/12. There is no issues about it. And for Earth is equal to 1 numerator and 12 is the factor for this number 1 to reach 12. So for Earth it becomes 12. So we have 1 by 1 is equal to 12 by 12. There is no issue in writing it like it. Now we have new numerators, and the prime factorization for these new numerators are, see here we are applying LCM. For 3 the prime factorization is 3, for 8 it is 2 into 2 into 2, and for 12 it is 2 into 2 into 3. So what is the LCM for this? The common factors 2, 2, 3, these are the common factors, and 2 is an individual factor. So we get 2 into 2 into 3 into 2. We can rearrange it. We can write as 2 into 2 into 3. So this becomes 24. Now when we get to this 24, what does this represent? What we need to do with this is that we need to multiply it by 1 divided by 12, that is the common denominator that we have got. So the first time when they will coincide is at 24 1 by 12. That is where we have applied LCM. It's the concept of LCM and LCM as well. What does the concept of LCM says? That it is the least common multiple or the first common multiple for 2 or more numbers. So the first time they meet, it will be the next time that they meet from now. So from 2020, the next time that they are going to meet is the first time that they are going to meet again after 2020. So that is why we have used LCM. We have applied LCM, and we have used the concept of LCM over here. So that becomes 2, and 2020 plus 2 is 2022. Now let us check it with another method quickly. Now method 2. We work out the 3 number series like this. Earth completes its encircling around the sun in its orbit in 1 year, then 2 years, then 3rd, 4th, and so on. Mercury, when we represents its encircling in its orbit around the sun in terms of Earth here, that is the data that we have got. So first it at 1 by 4, the second is as 2 by 4, third is at 3 by 4, and then so on. And for Venus, it is the first time 2 by 3rd of Earth here, the second encircling is at 4 by 3rd, 6 by 3rd, and so on. So Earth has to go around the sun 2 times for it to line up again in the orbit of Mercury and Venus. Why do we say it? The reason is that the first time when it becomes the whole number, it gives a product, is over here, and in this case Mercury, it is over here, and that whole number is 2. So that means when Mercury completes its 8th encircling around the orbit, then it completes 2 Earth years, and similarly Venus, when it completes 3 encircling in its orbit around the sun, it completes 2 Earth years. So the first time that we are matching it with the Earth is at 2, the number 2, when Earth completes 2 years. So when they will come in line together. So Mercury has to go around the sun 8 times, and Venus has to go 3 times. So that means the number 2 has to be added, 2 years has to be added to the present year, that is 2020. So the first time they all come in line of one another is at 2 years from now. So 2020 plus 2 is 2022. Hope you enjoyed. You saw that we have cross-checked what we calculated in both the methods. Now still, if you have any query related to LCM, then send us WhatsApp on 700-461-4975. Shoot us your questions, shoot us your query, we will answer. But do mention your name, age, class, school, and city. That will help us in providing you better solution. Now going ahead, we'll have more concepts, more learning, more fun. Stay tuned. Goodbye. Thank you.